So now we're going to look at trigonometry and bearings. In surveying and navigation, directions can be given in terms of bearings. A bearing measures the acute angle that a path or line of sight makes with a fixed north-south line, so our y-axis here. For example, in the figures below, the bearing south 35 degrees east means 35 degrees east of south. North 80 degrees west means 80 degrees west of north. And north 45 degrees east means it's 45 degrees east of north. So notice bearing has to do with our y-axis. So we're going to find directions in terms of bearings. So here is an example. A ship leaves port at noon and heads west due west at 20 knots or 20 nautical miles per hour. At 2 p.m., the ship changes course to north 54 degrees west as shown in the figure below. We define the ship's bearing and distance from port at 3 p.m. So what's important to note is, number one, we have 20 knots. 20 knots is 20 nautical miles per hour. Okay, miles per hour, really important because some other problems that we're going to have next will have to do with this, and so you have to remember that it's 20 knots is miles per hour. So it starts at noon. And then notice that it changes direction at 2 p.m. So there's it goes 2 hours at 20 knots. So that therefore this side length here is 40 nautical miles. Then at 2 p.m. it changes course. So it goes north 54 degrees west here. So it makes that angle. And notice here's the 90 degree. And then here is our, we can make a right triangle there. And then we want to find the bearing and distance from port at 3 p.m. So it does travel 1 hour at 20 nautical miles. So we know that is 20 miles there. So let's take a look at some pieces that we want to solve. So let's take a look at the degree here. How many degrees is that angle? So if this right side is 90 degrees, this should also be 90 degrees. So therefore, to find this angle here, we take 90 degrees minus 54 degrees, and that gives us 36 degrees. So we have 36 degrees for this triangle here. So let's use sine of 36 degrees equals b over the hypotenuse, which is 20. So let's solve for b. I'm going to multiply by 20 to both sides. And so now we know that b equals 20 sine of 36 degrees. So that's an important piece, so I'll leave that there. The other thing we can use is let's figure out what d is. And so we can write sine of 36 degrees equals, not sine, we're going to use cosine of 36 degrees equals d over 20, and so we're solving for d, multiply by 20 to both sides. So therefore we know that d equals 20 cosine of 36 degrees. So we're trying to find distance from port, which is c here. And so we need to go back and look at this angle here at A. So we know tangent of A equals opposite over adjacent. So opposite is our B over the adjacent, which is D plus 40 nautical miles. We do know what B is, and we also know what D is from our other equation. So we know that B here is the 20 sine of 36 degrees, and then we know D is the 20 cosine of 36. So let's go ahead and plug that all in. Tangent of A equals 20 sine of 36 degrees over D, which is 20 sine of 36 degrees, and then plus this 40 nautical miles. So then you can solve this entire right side here. So we can say, after you plug that all in the calculator, that you would see that tangent of A is approximately 0.209. Then we really want to solve for the angle. We need to know that angle A. So we're going to say that that's A equals arctan of 0.209. Then when you plug it in, you find that A is approximately 11.8 11.80 degrees. So this is 11.80 degrees here. So then we have to think about our bearing. We need to know what this angle is here. So if this is 11.80, we want to know this angle here because we're looking at how far is it from the y-axis. We can say that the bearing is 90 degrees minus whatever this a value is, right? Because we know the sum of the interior angles of the triangle should be 180, and we know this is 90 already. So this is 90 minus 11.80 degrees. And so when you do that, you find that that answer is 78.2 degrees. So remember how we write that. We write the bearing is north, so we're going north, 78.2 degrees, but it's traveling to the west, right? North, and here's west, so it's going this direction, so it's going north 78.2 degrees west. So that's the first thing. We found the bearing. Now we need to figure out what C is. So we do know this angle here, so let's try to use sine of A. So sine of A equals B over C. And we're trying to solve for C, so let's multiply by C to both sides. So we get C sine of A equals B, and then we know what sine of A is, and we also know what B is, so let's divide by sine of A. So this is C equals B, and B, remember B is this value up here, 20 sine of 36 degrees, all over sine of 11.80 degrees. So you plug it in your calculator, and once you do that, the answer will be 57.5 nautical miles. So try this example here. A sailboat leaves a pier heading due west at 8 knots. After 15 minutes, the sailboat changes course to north 16 degrees west at 10 knots. Find the sailboat's bearing and distance from the pier after 12 minutes on this course. So remember that one knot is 1 nautical mile per hour. So we're in a different, we have different units for time, so make sure you do the conversions for that as well. So here are the answers. So first thing you need to do is convert the knots in minutes to nautical miles per hour. So we went 8 knots in 15 minutes. That ends up being 8 nautical miles. Then the other one is 10 knots in 12 minutes. And so therefore you have to convert that as well. And that ends up also being 2 nautical miles. And so that's what you label up at the top here, right? So this is 2 nautical miles, and this is also 2 nautical miles. And then you can do the triangles like you did before. Okay, so once you figure that all out, take a look at what happens here. So we figured out that B is 74 degrees. Then you can write sine of 74 to find out what B is. Use cosine to find out what D is. Then we need to find this angle here to find our bearing, and so we use tangent of A and then B over D plus 2 nmi, substituting what we need, and then we find that the angle is 37 degrees. Here, 37 degrees. Then to find the bearing, you take 90 minus 37 degrees, that's 53 degrees. Then remembering that is traveling northwest, so the bearing is north 53 degrees west. Then the last thing you do is finding the distance C here. What is the distance from where it started? And so you can use sine of 37 degrees equals B over C, and then plugging in B is 2 sine of 74 over sine of A, which is 37 degrees, and then you would get 3.2 nautical miles.